Hi, my name is dr. Ahmath. In this video lecture, we are going to talk about the trigonometric functions. So in a previous video, we defined the trigonometric ratios on the triangle with the right angle. So essentially, this angle is the 90-degree angle, and we would like to define the sine and cosine of the alpha. The beauty of the right angle triangle is that there is the Pythagoras theorem which applies for this. So essentially, the sum of the squares of the shortest sides of the triangle is going to be equal to the square of the longer side. So it allows us to find the side of a triangle if we know the other two sides of the triangle. So we define the sine of the alpha as the ratio of the opposite side, right? So the opposite to this angle divided to the hypotenuse. And the cosine of the alpha is defined as the adjacent side, x divided to the r, to the hypotenuse. So now the problem is the values for the angles inside the triangles are limited. And at the same time, what we want is we would like to define the sine or the cosine of the alpha for 360 degrees, let's say, or 480 degrees, or 720 degrees for the large angles, or arbitrary any angle. So this alpha can be any angle. So I would like to define this. And it's going to be really difficult to define the trigonometric functions inside the triangles. So that's why we're going to use the unit circles in order to define the trigonometric functions. So let's first of all define what's a unit circle. So any circle whose radius is equal to the 1 is going to be called as a unit circle. So essentially, if I'm given the circle, then the radius of the circle should be equal to the 1. So what does it mean that the radius is equal to the 1? It means that if you choose any point on the circle, for example, this point, with the coordinates, let's say 3 over 5 and 4 over 5, for example, then the distance between this point and the origin of the circle with the coordinate 0, 0 is going to be equal to the 1. So this distance is going to be equal to the 1. So please note that we can find the distance by just subtracting the x coordinates, right, of these 2 points. So it's going to be 3 over 5 and squaring them, plus the subtraction of the y coordinates and squaring them is going to be 4 over 5 in the square, then taking the square root. So this is essentially is going to be equal to 9 over 25 plus 16 over 25 from the square root. It's going to be equal to the 1. So this is what does it mean that unit circle. So the radius is equal to the 1. The distance between any point on the circle and the origin is going to be equal to the 1. So please note that when you draw this point with the coordinates 3 and 5, 3 over 5 and 4 over 5, we could just make a triangle here, right? Or we drew this point 3 over 5. What does it mean? It means that if you would just have the x-axis here, and if you would have the y-axis here, then if I just make the perpendicular line from this point onto the x-axis, the length of this line is going to be equal to the 4 over 5, essentially the y coordinate of this point. And at the same time, this length, the length of this blue curve is going to be equal to the 3 over 5, essentially the x coordinate of this point. So this is going to be our idea how we are going to define the sine and the cosine of this angle alpha, let's say. So let me draw all of these pictures one more time in order to just define the trigonometric functions in general for any point on the unit circle. So let's say again, we are given the unit circle whose radius is equal to the 1. So what we want is we would like to just choose any point on this unit circle with the coordinates x and y. So since this is the unit circle, then the distance between any point and the origin is going to be equal to the 1. So essentially x in the square plus y in the square should be equal to the 1, right? So it means that the distance between x and y and the origin is equal to the 1. and distance between x and y and 0 is equal to 1. Okay, so now what I want is I would like to define the sine and the cosine of this angle alpha. In order to do this, I'm going to make a triangle here. So my triangle is going to be like this. So first of all, this is going to be this side of the triangle, and then I'm going to have this side of the triangle. So since I know the coordinates of this point, it means that I know the length of the sides of the triangle as well. So the length of this side is going to be equal to the y, and the length of this side of the triangle is going to be x. And at the same time, since I'm on the unit circle, so since this point is on the unit circle, the length of the side is going to be equal to simply 1, right? And if you remember, we define the sine of the angle as the opposite side of the, so this is the right triangle, right? So the sine of the angle is going to be equal to the y divided to the hypotenuse, which is equal to the 1. Or simply, it's going to be equal to the y. And the cosine of the angle is going to be equal to x divided to the hypotenuse, which is equal to the 1, or simply it's equal to the x. What does it mean? It means that instead of just writing down the coordinates of this point as the x and y, what I could do is I could just write this down as the sine of, it's a cosine of the alpha, and the sine of the alpha for this angle, right? Well, essentially, if you know the coordinates of a point on the unit circle, then these coordinates are going to be the values of the sine and the cosine of the alpha. So let's define a couple of values of the sine and cosine on the unit circles. So let's say I'm going to make a table and I'm going to try to fill this table out. So let's make a table first of all for the sine. So let's say I've got the table. I would like to figure out, for example, if the alpha is equal to the 0, what is the value of the sine of alpha? So if the alpha is equal to, let's say, pi over 2 or 90 degrees, what is going to be the value of the alpha? If the angle is equal to the pi or 3 pi over 2 or the 2 pi, what are the values of the sine? And again, I would like to draw a unit circle. So let's say this is going to be my unit circle, right? So and this unit circle is on the xy coordinate system, let's say. So this is going to be the x-axis. And I'm going to have again the y-axis as well here. So this is going to be the y-axis. So what does it mean that the angle alpha is equal to the 0? It means that this point, the always the angles are between the two rays, right? The initial ray and the terminal line. Okay, so whenever we are going to define these angles alphas for the standard case, the initial lane is going to be equal to along the x-axis. The terminal line is going to be on the top of this when alpha is equal to the 0. So I need to define the coordinates of this point, and it's clear that since I'm on a unit circle, the coordinates of this point is equal to the 1 and 0, right? And if you remember that the y coordinate of a point on the unit circle defines the value of the sine of angle, right? So here I've got a 0, it means that when alpha is equal to the 0, the value of the sine is equal to the 0. Now we need to go further. So if the angle is equal to the pi over 2, so basically if I would just rotate the terminal line to exactly pi over 2, so let's rotate the angle to the pi over 2, then I would have this terminal line, right, at this point, and the coordinates of this point is equal to the 0 and 1. Right? This is essentially on the unit circle, so that's why the points coordinates are going to be like this. And again, the y coordinate of this point is going to tell me what is the value of the sine of pi over 2, right? The y coordinate of this point is equal to the 1, so that's why the sine of pi over 2 is going to be equal to the 1. And again, I'm going to go further on the points on the unit circle, so let's define this point, which is equal to the pi, right? If you just rotate the terminal line until here, the angle is going to be pi, and the coordinates of this point is equal to minus 1 and 0, right? And again, the y coordinate of this point is 0, so that's why the sine is going to be equal to the 0. So if you go and rotate your angle until 3 pi over 2, until here. So this is 3 pi over 2, right? Then we're going to have the point here, and the coordinates of this point is equal to 0 and -1. And if you look to the y coordinate of the point, it's going to be equal to the -1. So that's why the value of the sine of 3 pi over 2 is going to be equal to the -1. And the last point in our table is simply 2 pi. So the 2 pi is again this point, and the y coordinate of this point is equal to the 0. So this is going to be 0. So we can figure out the values of the sine for any angle now by just going through the points on the unit circle. For example, if I would just say, hey, could you please tell me what is the value of the sine at the 5 pi, for example, right? What does it mean, the 5 pi? It means that you need to rotate the terminal line around the circle twice. One time it's going to be 2 pi, then one more time it's going to be 4 pi, then just until here, until half of this, it's going to be equal to the 5 pi. And what is this point where I get this? This point is going to be -1 and 0, and the y coordinate of this point is simply equal to the 0, so that's why it's going to be equal to the 0. Okay, so we can define now the sine for any angle, right? And again, we can define this for the negative angles as well, right? For example, if you remember, if you just rotate the terminal line in the clockwise direction, you can define the angles, negative angles, right? So this angle is going to be equivalent to the minus pi over 2, not plus, because we're moving in the clockwise direction. And you can see this point is going to have the coordinates 0 and -1, so that's why the sine at the minus pi over 2 is going to be equal to the -1. So essentially, defining the trigonometric functions on the unit circle reveals lots of features of the trigonometric functions, essentially the values, their sign, their properties, and so on. So now let's try to make a similar table for the cosine of the alpha. So again, I'm going to make a table for the different values of the alpha. And I'm going to figure out the values of the cosine for that alphas. So again, I'm going to draw a unit circle here. This unit circle is going to be on the rectangular coordinate system. And again, this circle is unit implies that the distance between between any point and the origin of the circle is going to be equal to the 1. Right? This is what does it mean. So again, I'm going to define the angle for the 0, let's say pi over 2, pi, 3 pi over 2, 2 pi, let's say 5 pi, okay, or the negative minus pi over 2. So the same points as before. So let's say when the angle is 0, this is going to be this point, was the coordinates 1 and 0, right? Now, if you remember, the x-coordinate of the points on the unit circle are going to define the cosine of the angle, right? Because the cosine of the angle is this x divided to the hypotenuse, right? So simply cosine of the angle is going to be x-coordinate of the points on the unit circle. And the y-coordinates of the points on the unit circle define the sine of the angle. So what is the value of the x-coordinate of this point? Well, it is equal to the 1, so that's why cosine of the 0 is going to be equal to the 1. Now I'm going to rotate the terminal line to the pi over 2 in order to get this point was the coordinates 0 and 1, right? And you see, so the x-coordinate of this point is equal to the 0, so that's why the value of the cosine of pi over 2 is going to be equal to the 0. So now we're going to draw the angle until here, so we are going to like rotate the terminal line until here in order to get this point, for example. The coordinates of this point is equal to the -1 and 0, and the x-coordinate of this point is equal to the -1, so that's why cosine of pi is equal to the -1. Essentially, cosine of minus pi is also equal to the -1, right? Because in order to get the minus pi, you need to rotate this terminal line in the direction of the in the clockwise direction, right? And you essentially are going to get again the same point here with the same x-coordinate, which is equal to the -1. So at the minus pi, it's going to be equal to the -1 again. So now let's define the cosine at the 3 pi over 2. In order to get the 3 pi over 2, we need to rotate this until here, right? So again, so the coordinates of this point is going to be equal to the 0 and minus 1. So since the x-coordinate of this point is equal to the 0, so that's why cosine of 3 pi over 2 is going to be equal to the 0 again. So 2 pi means that we need to get back to the original point, right? So again, one time rotation around the circle is equivalent to the 2 pi of the 2 pi angle. So and this is going to be equal to the 1 again, okay, because the x-coordinate of this point is equal to the 1. So now, if you would like to define the cosine for any angle, any large angle, for example, 5 pi, what does it mean? 5 pi means that you need to rotate the terminal line. So let me just erase it so that we can see everything well. So you need to rotate the terminal line once. It is going to be 2 pi. Then one more time, it's going to be equal to the 4 pi. Then the half of this, it is going to be equal to the 5 pi. So this angle is 5 pi. What point you get is this point, and the x-coordinate of this point is equal to the minus 1. So that's why 5 pi is going to be equal to the minus 1. So at the same time, minus pi over 2 means that you need to rotate the terminal line in the clockwise direction. So this angle is going to be equivalent to the negative pi over 2. And the value of the cosine is going to be equal to the 0 because the x-coordinate of this point is equal to the 0. So this is how we can define the sine and the cosine for arbitrary angle. And the key idea is that you need to have these functions on the unit circle. So in our next video lectures, we're going to discuss about the properties of the trigonometric functions. So I hope that this video was helpful for you.